Hello everyone, this is your tutor AB, and today we're going to be solving a problem from the November 2018 IB physics examinations. This is a paper 2 HL question and it's open-ended, relating to the topic of mechanics. So let's get started. A chicken's egg of mass 58 grams is dropped onto grass from a height of 1.1 meters. Assume that air resistance is negligible and that the egg does not bounce or break. Define impulse. Now, refer to your data booklet and find out what's the equation for impulse. J is equal to F delta T, isn't it? But impulse J can also be written as the change in momentum. So that's essentially the definition as well. We can just say impulse is the change in momentum. That's it. That's your definition. Okay, so let's go to the next question. Show that the kinetic energy of the egg just before the impact is 0.6 joules. Now what we need to understand is that every object at a point in space has some potential energy, and as it moves or is in motion, that potential energy is converted into some kinetic energy. So in this case, you have a floor and you have an egg, right? This egg was dropped this way. It used to have some potential energy, and that potential energy got converted into kinetic energy, and as it's right before the egg touches the ground, we can roughly say that the potential energy mgh is equal to the kinetic energy ke, right? We can just say they're about equal because it's towards the end of the motion, end of the egg's motion. So if mgh is equal to the kinetic energy, in this case, we can just simply do some substitution and we can get our answer. We know the mass of the egg is 58 grams, which we need to convert to kilograms, so we get 0.058 kilograms into gravity. Let's take it as 9.81 times the height, which is 1.1. So if we put this all into our calculator, we will get the answer to be 0.058 into 1.1 into, we get the answer is equal to 0.62 joules, and 0.62 is roughly equal to 0.6. So that's how we derive this. Okay, next part. The egg comes to rest in a time of 55 milliseconds. Determine the magnitude of the average decelerating force that the ground exerts on the egg. Now, how do we solve this? We know that F is equal to ma, right? But we don't have all the necessary things to find this. We don't know acceleration. We won't really be able to calculate acceleration. At least even if we are able to, that's not very feasible for this question, as it will take too long. So there's probably a more direct way to solve this question, and that's using conservation of momentum. Or not even conservation of momentum, just the impulse equations. J is equal to F delta T. This is the equation for impulse. Essentially, if we rearrange this equation, impulse by the change in time, we can find out the force that is exerted on the egg from the ground to decelerate it. So how will we solve this? So how do we solve for this impulse? Because we know the time, but how do we solve for impulse? Well, impulse is nothing but, we know from the start, is the change in momentum, right? So it's just momentum final minus the momentum, sorry, I should write it properly, momentum initial. So let's just find out what's the impulse. So the mass, of course, is constant, so that's 0.058. let's take that, actually no, let's not do anything too complicated, into the final velocity. Now how will we calculate this final velocity before anything? Well, let's leave this to one side, right? To calculate final velocity, we can use the equation v square is equal to u square plus 2as. These are our Suvat equations. suvat, right? So let's calculate it. So v square is equal to u square, it starts at rest, so 0 plus 2 times the acceleration 10, or let's not use 10, let's be accurate here, 9.81 into the displacement 1.1. So v is equal to the root of, and then if we calculate what this comes out to be, 2 into 9.81 times 1.1, v is equal to, let's put this in a calculator, 2 times 9.81 times 1.1, v is equal to 4.65 meters per second, and that's the final vertical velocity just as it's about to hit the ground, right? So we can say, let's just make more space for this, 0.058, which is the mass, times the final velocity, which is 4.65, minus again 0.058 times the final, minus the initial velocity, times the initial velocity, and we know the egg was initially at rest, so that has to be 0. So this essentially just cancels out, we don't need that. So the impulse j is equal to 0.058 times 4.65. Now if we calculate this, right, to 0.058, we get j is equal to 0.27, but that's not what we need. We need 0.27. We actually need to find the force, right? So how will we find the force? Let's solve it. Okay, let's delete this portion. Right, we already know. We know that f is equal to j delta t. We know j, so we can put this into our equation. F is equal to 0.27 divided by 55 milliseconds. So that's 55 into 10 to the power of negative 3 seconds. Now we put this in our calculators, we will get, so we get the answer is about f is equal to 4.9 newtons. That's the magnitude of average decelerating force that the ground exerts on the egg. That's the answer, 4.9 newtons, which we could round to 5 newtons, but I'll just keep it 4.9. And finally, explain why the egg is likely to break when dropped onto concrete from the same height. Now, how will we solve this question? This is some theory here, but it's nothing too hard, okay? Essentially, if you think of a ground, the grass can serve as a cushion, right? The grass serves as a cushion. So what does this do? The grass actually increases the stopping time, right? It gives the egg some more time before it truly hits the ground. It increases the stopping time. Whereas with concrete, the concrete actually reduces the stopping time. There's no cushion. And as a result of this lesser stopping time, the deceleration is also greater. So the force from the ground exerted onto the egg is greater. So the egg feels a greater amount of force and it is more likely to break. That's essentially it. We can say in words that there is no cushioning, right? If that's a word, cushioning from the concrete, so there is a reduced stopping time. That can be 1 point. The second point can be that deceleration hence is also greater, so force is greater, and so egg is more likely to break. Essentially, this point just comes from f is equal to ma. There's a direct proportionality between a and f. If acceleration is greater, force is greater, and so these 2 points work. These two are some possible answers for this question. If you think of anything else, you could use that as well. These are just some ideas you can use to get started. Now I hope that all this makes sense, and see you in the next video.